Good morning. Yesterday we looked at the transformation of a function from its parent function, and we looked at writing the rule for that transformed function, describing that transformed function, as well as graphing that transformed function. Today we want to generalize that to any function, not just the absolute value and the quadratic functions. So here before you, you have 5 problems where I'd like you to write the function rule in the form of g of x equals for the following transformations of f of x. I'll give you a few minutes to do that. Okay, so for the first one, we're translated down 4 units, so that's k equals 4, negative 4. Right? So then that the function is applied, I have x, the function is applied, and then I subtract 4. The second one translated 3 units left. That means h is negative 3. 2 units up, k is 2. So I have the absolute value of x minus, and then remember the general form has x minus. Then I look at h, and I see a negative 3, so that minus becomes plus, x plus 3. Absolute value is applied, and then I add 2. K is 2. For the third one, I reflected about the x-axis. We talked about how a becomes negative. So here a is positive 3. Now a becomes negative 3. For number 4, reflected about the x-axis. Again, a becomes negative 1, and translated down 4 units. K is negative 4. So it gives me negative x squared, and then minus 4. And then finally, stretched vertically by a factor of 4. Here a is going to be equal to 4. And that's the warm-up. Now let's generalize for any function f of x, today's lesson. Here we have a similar familiar statement, except I don't have f of x equals anything. It's just f of x. So g of x is the graph of f of x translated 5 units right. Then I'm going to write 5 units. What's h? If I go to the right, it's positive, so h is 5. So if g of x equals, what to write here? Remember we said that if I'm moving right or left, that happens to x before the function is applied. So we can think of the f of as the function being applied. So this x, I need to add 5 to it before the function is applied. So that 5 will go inside the parentheses with the x. And that's it. Okay? So we don't know what the function is, so we'll just leave f of the input. For the next one, graph of f of x translated 2 units down. Here k is negative 2. And remember we said yesterday that k is what happens to the function, what happens after the function is applied. So I have x, I apply the function, and then I'll move down to. Okay. G of x is the graph of f of x translated 4 units left and 6 units down. If I move 4 units to the left, that means h is negative 4. Down 6 units, that means k is 6. So I have g of x equals f of x. Here, we have a minus in the general form, but the negative 4 makes it plus. So I add 4 to the x before the function is applied. Then I apply the function f of, and then I need to subtract 6, because 6 units down is negative 6. 9, stretched vertically by a factor of 4. So it's going to be g of x equals 4 times f of x. Remember that stretch is applied after the function, so it goes outside of the function. Okay, we're going to be reflected about the x-axis. So a equals negative 1. Translated up 2 units, k equals 2. So that's g of x equals negative f of x plus 2. Last one, compressed, shrunk vertically by a factor of 5, then reflected about the x-axis. Okay, reflected about the x-axis, a is going to be negative. But what does it mean to be shrunk by a factor of 5? Well, you know if you're stretched by a factor of 4, just have a 4. How would I do a shrink? It's going to be the opposite of multiplying by 5. In this case, the factor is 5. The opposite of multiplication is division. So I'm just going to multiply either by 1/5. Think of it as dividing by 5. So I'm going to multiply by negative, because I'm reflecting about the x-axis. And then I'm dividing by 5, or multiplying by 1/5. So we have g of x equals negative 1/5 f of x. Okay, now here the graph of f of x is given. Graph the related given function g of x. Hint, first plot the translation of key points of the graph of f of x. Okay, so this is f of x here. Okay, and this is going to be a conceptual exercise. Okay, g of x equals f of x plus 2. Plus 2. Remember, this 2 is happening after the function is being applied. So we're actually going to shift up 2. Or you could say k equals 2. So I want to take this entire graph and shift it up 2. Well, the important points are the starting points and then the break points. So this point here is important. Shift up 2. This one, shift up 2. Okay, now the points in between are important, but you can see that if I know it's a straight line, if I get the starting and ending points of that straight line, then I can graph the rest of it. It's another important point. Shift it up 2. And here, shift it up 2. And now I can draw the graph. And there you go. Okay, give the next two a try by pausing the video and then unpause it to see what the answers are. Okay, here we go. For 13, we have a shift left 1. So I took this point and I shifted it left 1. I took this point, I shifted it left 1. And then I took this point and I shifted it left 1. And then I just drew the graph. For the last one, I shift right 2 and up 1. So I took the break points in the graph, I shifted them right 2 and up 1. Here I shifted this one right 2 and up 1. And this one I shifted right 2 and up 1. And then I just drew the graph. Okay. So if you drew these graphs by looking at the shifts, then conceptually you understand what's going on when we talk about transformations of functions. Okay, we looked at the generalized case, so it doesn't really matter what the function is. You know by looking at it what the shifts are, and that's what's important. Now you have a second paper for homework practice. Time in class, go ahead and get started now. On the bookshelf under the window there should be enough books so that we have one book per table. Go ahead and share and get this exercise done in class so you won't have any homework. And that is it for today's lesson. If you have any questions, discuss amongst yourselves, but you can also email me if you have any questions. Thanks.